Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. See, up to now, we have seen various topics in engineering tribology. So today, I want to discuss about some topics related to lubricants. The specific selective topics we will see in this session. You know, the friction and wear and lubricants are very important role plays in engineering tribology subject. You have to know more knowledge about these three: friction and wear and lubricants. So whenever two surfaces are in contact each other, there is a friction and there is a wear. So to control these friction and wear, you must use the lubricants. So by using these lubricants, you can minimize the friction, you can minimize the wear. So now we will see about lubricants topics. The lubricant is a substance which is used to control friction and wear of the surfaces in contact of the bodies in relative motion. So used to control the friction and wear of the surfaces wherever two bodies are in contact position. What is this evaluation of lubricants? The history of lubricants started thousands of years ago. As early as in 2400 BC, by 1400 BC, Egyptians used animal fat to lubricate chariot axles. For their chariot axles, they were used this lubricant oil. The animal fat used as a lubricant oil. However, the solid theoretical understanding of the lubricant action was only possible with the development of the viscous flow. Viscous flow laws, very important. Already we have studied the viscous flow laws. So discovered by Sir Isaac Newton in 1680s. Early in the 20th century, only mineral oils, vegetable oils, and fats and greases were mostly considered as lubricants. So the lubrication mechanism, what is the mechanism behind this lubrication? So all the surfaces in nature are rough, at least microscopically. When two rough surfaces slide against each other, the asperities of the surfaces come close to each other and interlock, adhere and generate friction. The goal of any lubrication approach is to separate the rubbing surfaces by a lubricant layer, which prevents the direct contact of the bodies by choosing appropriate lubricant. The friction and wear of the materials can be controlled. Whenever two rough surfaces slide against each other, so there is the asperities of the surfaces come close to each other. So they classify types of lubricants based on its state. The lubricants can be classified by the state into following groups. The classification of lubricants are an important topic. Liquid lubricants. All liquid lubricants, including mineral, natural synthetic oils, emulsions, etc. The solid lubricant, all lubricants in a solid form, including powders, coatings, and composites. These are the graphite, polytetrafluoroethylene, molybdenum disulfide, etc. The gaseous lubricants, typically in its air, but can be any other gas, semi-solid lubricants, greases, generally consist of a soap emulsified with mineral or vegetable oil. So one is the lubricants are classified into liquid lubricants, solid lubricants, and then gaseous lubricants. So the gases they generally consist of a soap emulsified with mineral or vegetable oil. The state liquid lubricants. The liquid lubricants may be divided into the following groups. One is hydrocarbon based oils, natural oils and fats, non hydrocarbon synthetic oils, water containing lubricant. These are the four groups. State properties of liquid lubricants. There are several key pair of properties that determine the performance of lubricants. From the lubrication theory, respect to viscosity and density of a lubricant are the most important parameters. The viscosity is the factor that determines the thickness of a lubricant film that separates the surfaces. Higher viscosity, thicker is the film. See hydrodynamic lubrication for an example and equation. So the liquid lubricants from the lubrication of theory perspective, viscosity and density of lubricant. These two properties are very important parameters. So it determines the thickness of the lubricant film. Boundary lubrication. So the boundary lubrication associated with metal to metal contact between two sliding surfaces of the machine. During initial startup or shutdown of some equipment, that is journal bearing example, are under heavily loaded conditions, pins and bushings of construction equipment. The metal surfaces in a lubricated system may actually come into severe contact with each other. So the boundary lubrication is associated with the metal to metal contact. You can see in the journal bearing, the journal rotates inside the shaft and the inside the shaft bearing. That is called as journal bearing. Which portion of the shaft contact with the surface of the bearing? That portion is called as a journal. So that's why the shaft or journal both are equal, rotates inside a bearing. So under heavily loaded conditions, pins and bushings of construction equipment, the metal surface in lubricated system may actually come into this contact with each other. Just mixed lubrication. In mixed lubrication, the boundary lubrication is dramatically reduced as sliding speed increases, creating a wedge of lubricant film between the surfaces in a motion. As the potential for asperity contact is reduced and film thickness is increased, the coefficient of friction drops dramatically to the condition known as mixed lubrication. Next, aerodynamic lubrication. See, this lubrication regime occurs between sliding surfaces when a full film of oil supports and creates a working clearance. There is some clearance between the journal and the bearing surface. So the lubrication oil circulated in this gap. So in order for aerodynamic lubrication to be successfully and completely applied, there must be high degree of geometric conformity between the machine components and a resulting low contact pressure between the surfaces in a relative motion. So next, fluid film lubrication. This lubrication system condition occurs after a machine has begun to rotate and the speeds and loads are such that a wedge of oil has been formed between the shaft and bearing surfaces. This wedge of oil lifts the shaft away from the bearing surface. So there is a little risk of asperity contact. This is a desirable condition to avoid friction and wear. So in this fluid film lubrication, the machine has begun to rotate and the speeds and loads are such that the wedge of oil has been formed. So there is a two types of phenomena occurred in bearings, general bearings. One is wedge film formation and another one is the squeeze film effect. So whenever the edge formation occurred, then oil lifts the shaft away from the bearing surface. So there is a little risk of metal to metal contact. To avoid friction and wear, this is very desirable. Next, elasto-hydrodynamic lubrication. The elasto-hydrodynamic lubrication conditions occur when a rolling motion exists between the moving elements. The bearings are two types, you know, one is sliding contact bearings, another one is rolling contact bearings. When a rolling motion exists between the moving elements and the contact zone has a low degree of conformity, for example, note that the curve of the roller and the race in a rolling element bearing are very dissimilar. Next, role of lubricants. What is the primary functions of a lubricant? One is reduce friction. Another one is prevent wear. Third one, protect the equipment from corrosion. So control temperature, dissipate heat. So whenever there is a friction, so some heat will be developed inside the components. So that developed generated heat must be dissipated to the surroundings. Otherwise, the system will be fail. So how to control this temperature? So by using lubricants. So lubricants absorb that heat and dissipate it to the surroundings. Next, to control contamination. Contamination carries contaminants to filter or sump. The transmit power, hydraulics, provide a fluid seal, tight seal effect. So the lubricant also very useful, act as a fluid seal tightening. So generally the lubricants are used for these functions. Next, uses of lubricants. The lubrication is required for the correct operation of mechanical systems such as pistons, pumps, cams, bearings, turbines, gears, roller chains, cutting tools, etc. Where without lubrication, the pressure between the surfaces in proximity would generate enough heat for rapid surface damage, which in a coarsened condition may literally weld the surface together, causing scissor effect. The splash lubrication system. In these types of lubrication systems, the lubrication oil accumulates in an oil through your sump. A scoop or dipper is made in the lowest part of the connecting rod. So whenever the engine runs, the dipper dips in the oil once in every revolution of the crankshaft and causes the oil to splash on the cylinder valves. So this action connects engine valves, piston rings, crankshaft bearings, and large end bearings. The splash system mostly works in connection with the pressure system in an engine. Some parts being lubricated by the splash system and the other by pressure system. Next, a grease lubrication system. In this system, the greasing pumps provide a proper amount of grease to lubrication points. So the main systems used for grease lubrication are dual line and progressive systems. Next, dual line lubrication systems. The dual line system has a modular design that allows for simple configuration and expansion of the system. It is suitable for industries with large machines and many lubrication points. Iron and steel industry, cement plants, platforms, large cranes, and cargo handling equipments. The dual line lubrication systems are found in every industry in which requires continuous duty operation. So there are economical for systems having more than 20 bearing points, and points can easily be added without redesigning the entire system. Next, oil lubrication system. The oil lubrication system total loss lubrication. Oil or fluid grease creates a thin oil film that protects spots. This is renewed at regular intervals by an automated lubrication system with an electric oil pump. The main system utilized in oil lubrication are the single system and the 33-volt system. The minimum quantity lubrication is innovative new technology that replaced traditional and pure oil fluid systems in a machining environment. Fundamentally, the controlled compressed air stream carries a minimum quantities of cutting oil in an aerosol. The format to the cutting surface by external or internal through the tool lubrication. So this is the topics related to lubricants. So in this lubrication chapter, we have learned the definition of lubricant and the classification of lubricants, and what are the methods involved in this lubrication system: lubricant, hydrodynamic lubrication, bonding lubrication, and elasto lubrication systems we have seen. And also, we have talked about the important functions of lubricants and what are the properties of lubricants we have seen. And then the systems, various systems, the grease lubrication system, the splash lubrication system, and then the dual line lubrication systems, and the oil lubrication system, and minimum quantity lubrication systems we have studied. So these are the important topics in lubricant chapter. For these topics, I have taken references like this. So you can refer any one textbook for more information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.